So when looking at ellipses, we're going to use Desmos to help us kind of explore these a little bit, and eventually you will actually have some work to do on those. So we're going to start with a really basic ellipse, and our basic ellipse is just going to be x squared over, and what we're going to do is I'm going to make some sliders for a, and so x squared over a squared, and then plus y squared over b squared, and then that's going to equal 1. And we'll make these a's and b's sliders. And so you can see that when a and b are both 1, you get a circle with radius 1. But as we make these bigger, so for example, if I make a 5 and b 3, we start to see our familiar ellipse looking shape. And one of the things I want to point out on here is you can see that a, the part underneath x, is bigger, and so that is our major axis. And what we can actually do on here is we can do a calculation to find out what c is going to be. And so if we do c, it's going to equal, if you remembered, a squared is equal to c squared minus plus b squared plus c squared. So if we subtract the b squared and then take the square root of both sides, we can get, you just hit SQT to get square root, by the way. You get a squared minus b squared. And so that's a value for c. You can see it does the calculation here for c. And then from there, we can remember that as long as a is bigger than b, if a is not bigger than b, and I'll show you what happens here in a second when if we violate that, then this is what c would be. And so our foci are just going to be, because they're on the x-axis, our y value will be 0. So it's just going to be c comma 0 as a point, and negative c comma 0, and those would be our foci. And as we start moving a and b around, we can start learning out things. If you notice something interesting about ellipses, as you get closer and closer to a really narrow ellipse, you notice how the foci are almost on the graph. As you get closer and closer to where a and b are the same, you see what is happening with the foci. They're approaching each other until eventually when a and b are the same, the foci coincide with each other, because in that case, a and b are both 5, and so c just turns out to be 0. And in this case, it's just a circle. When you end up with a and b both being 5 or both being the same, you have this idea of a circle. But we can see how this affects our what our foci look like. Now, what we're going to do is, so far, this is making the assumption that we're centered on 0, 0. Well, I don't want to be centered on 0, 0. I want to move my graph off of 0, 0. So we're going to use the familiar notation of x minus h to do that, and then y minus k. Hopefully this should not be surprising to you that we're using those, where hk is going to be our center, and so we'll make those now sliders. And so you can see right now I've got h and k are 1, 1, and so now let's go ahead and make a point down here of hk. And so you can see this black point is our center of the circle, the ellipse. And so as we move our b down, it stays in the, you can see it stays in the center. Now, if you notice, one of the things that's happening here is my foci are not appropriately placed. And that's because the foci are always going to be on this major axis, and the major axis is going to be along the line where x is going to be equal to h and k, or k is going to be, y is going to equal to k. So what we do is we realize that the foci are just going to be h plus c and then comma k, because they need to have the same y value as the center, and then the x value is going to be shifted by the c value, and then h minus c comma k. And so you can now see where these foci are. So now as I start moving things around, if I make k bigger, it's going to move the graph up. You see that the foci move with it. It doesn't change the relationship between the foci and the center. Same thing here with h. As I move, it's just going to move it left and right. And so the key here is recognizing, oh, this foci is just on this major axis that's happening. Now, one thing I did want to point out is that with c equaling a squared minus b squared, If I take A and make it less than B, notice the foci went away. And the reason the foci went away is because inside this square root, I would have 4 minus 2.6 squared, which is a negative number, which is imaginary, and so it can't actually do the calculation. And so when you remember the one that's under the y is bigger, then you've got to reverse these around. Mine up here in my equation, I'm using the a is under the x and the b is under the y. And in that case, when you're finding the foci, well, the c needs to be added to the k and subtracted from the k, because now the foci will be on the major axis, which in the case of the number under the y being bigger is the major axis now becomes the vertical line instead of the horizontal line. So that kind of gives you an idea of what happens as you mess around with these h and k, but it's really not hard to come up with the graph using these. The other thing I want to look at is a hyperbola. We won't go into quite as much detail because you can't see things quite as well, but we will just look at the graph of it. So a normal hyperbola would be something like x squared over 9 and then minus y squared over, let's say, 16 equals 1. And so this is what the hyperbola would look like. The y is the one being subtracted, so it opens left and right. Note that if you change that around and let this be the y and this be the x, you get a hyperbola, but it's opening up and down. And then it turns out that your center is going to be their point in between these. And so it's going to just be, just like in the ellipse, you can use this hk. The k goes with the y. The x goes with the h. So you get y minus k squared over 9 minus x minus h squared over 16 equals 1. And so we create sliders for these. And now we can see, oh, I can move my hyperbola around by changing these h and k's. The box that you would create, remember when we do a hyperbola, we use 3. So the distance from the center, in this case, if our center is 5 comma 1, right, that would be right here. And so the distance up would be 3, so you can see where it goes up to 4 and then down to -2. And then the box would be 5 over, in this case 4 over, and so it would come over here to help you find your asymptote, so when you go through and draw it. But I just wanted to show you how the h and k can affect a hyperbola just like it affects ellipse. They're very similar to each other. And then when you get to the foci of the hyperbola, you do have to go through and think through, okay, I calculate the c different. Remember, in a hyperbola, the c comes from a squared plus b squared equals c squared. So it's bigger than either one of them. And that's going to get your foci to be up into here. And then what you do is you just take that center point and you add c and subtract c to it, but c is bigger, so that's going to allow you to be inside the hyperbola where the foci should go. So there's a lot of logic that you use to help you kind of think through, where would that foci need to be? What do I need to do to kind of create that? Allows you to come up with, instead of having to straight memorize everything when it comes to these hyperbolas and ellipses.